Welcome to yet another very interesting episode of Basic Science. Today we want to look at radioactive or radioactivity, where we talked about radioactive substances. Now you cannot mention this topic, radioactivity, without acknowledging the scientists that did this discovery. The phenomenon of radioactivity was discovered by a scientist known as Henry Becquerel. That was in 1896. Henry Becquerel was a physicist, a scientist that was studying emission. And one of his findings, he discovered that there are some particles that have the ability to penetrate other substances and even go as far as disintegrating them. So because of that, this man carried out some experiment that shows that a substance, an element known as uranium, was able to give out some kind of particles. And those particles given out were able to penetrate through thick black papers and affect the photographic plates placed at the other side. And he called this process radioactivity. Now, what did he do? He worked on uranium. And as he's working on this uranium, he discovered that uranium has the ability to penetrate. It can enter into a substance and come out of the other side. And not just entering into this substance, it was able to react on the other side that was very thick with a black paper. And when this happened, he said no, that this must be a radioactivity taking place. That is why he named that process radioactivity. Now, in definition, radioactivity is the spontaneous decay or disintegration of nucleus of an atom. What is an atom? You did that last time in your second term. He said an atom is the smallest particle of an element that can take part in a chemical reaction. And this atom has what we call the nucleus. You know, when you look at an atom, we have the neutron, we have the electron, and we have the nucleus. So these are the parts of an atom. And this man discovered that there was a spontaneous decay in the nucleus of an atom, of an element, during which it emits or gives out three different particles. It gives out alpha particles, it gives out beta particles, and gamma particles. Or, in most cases, these three combinations were given out, including heat. So that was what radioactivity was all about. And in today's world, this radioactivity has been used in various technologies, which we are going to see in our next class, in our next slide. Now let's look at types of radiation. Don't forget that when we talk of radiations, we are looking at radioactive emissions. So let's look at types of radiation and their properties. We'll start with the first one, that is alpha radiation or alpha particles. Now, the particles have equal mass to that of helium in nucleus. Helium is an element in the periodic table. The element number 2 is helium. So now these alpha particles have equal mass like that of the helium. So that is their first property. Another property of alpha is that it travels a short distance in air. They don't go far, unlike light that travels very fast and can go a long distance. But these alpha particles travels very short. The third point is that the particles have little penetrating power. So note that alpha does not penetrate much like other radiations we are going to see. They have short penetration power. Fourthly, they are positively charged. Alpha particles are positively charged. The last point we consider is that particles are deflected by electric and magnetic fields. So when you carry an alpha particle close to an electric field, it deflects it completely. If you take it close to a magnetic field, it equally deflects it. So if you want to denature alpha, just introduce them to electric or magnetic field, it will destroy them completely. Now let's look at the second particle, the second property, being beta particles or beta radiations. Please do not forget the symbols. This is a symbol for alpha, and this is a symbol for beta particles. Now, the particles are negatively charged. Try to compare that with this. Alpha is positively charged, while beta is negatively charged. Their penetrating power is intermediate. They are not short or little, and they are not much. So they are in between. Unlike alpha, alpha already has a little penetrating power. This one is not too little and is not too much. The third point is that the particles are deflected in opposite direction of alpha particle. That is what it means is that when you bring beta particle out and you introduce them to an alpha particle, you see that the particles, instead of moving this way, they will be going in an opposite direction. So it is being opposed by an alpha ray. That is one important point you should note. And finally, they have a negligible mass. Their mass is very small, unlike alpha that is equal to helium. This one is relatively very, very small. Let's go to the uses of radioactivities. How are they used in today's world? Mostly in medical field, they are really used. One, it is used medically in the treatment of cancer. So some cancerous cells are passed through these emissions, and when they are passed through this emission, they have curative ability. For example, skin cancer, if it's introduced through these radiations from radioactive substances, it cleans the cell and causes healing to that area. Two, it is used industrially to monitor and control the thickness of sheet materials. It can be controlled when it's passed through radiations. Materials such as plastics, that is why you see that some plastics are very thick, some are thin, some are very, very light. And when they are producing it, one will not be thicker than one because they are being measured using radioactive rays. Even in metals, some metals are very thick, some are thin. The equality or uniformity is being made possible through radiations of radioactive substance. Now let's see point 3. Radioactivity is used for sterilization. Sterilization mostly in medicine. Sterilization simply means the killing of germs. Now when these germs are in our equipment, mostly surgical equipment, they can transfer germs from one patient to the other. So before equipment are being used in the laboratory, they are sterilized. Even in microbiology, when they want to culture a cell, they want to culture a particular strand of bacteria, before they do that, the Petri dish and everything that should be used for that culture practice must be sterilized. And how do we sterilize this? By putting them in a centrifuge that has radioactive ray. Number 4, it is equally used in agricultural purposes, especially in carrying out researches on improving soil content. The pedologists, the science of studying soil, make use of this. From these rays, they will be able to ascertain the kind of soil, the water carrying capacity of the soil structure, the soil texture, everything about that soil can be carried out using radioactive rays. Number 5, it is used in carbon dating by archaeologists. They use that to know the age of a carbon. Remember, I told you in one of our episodes that carbon is coal can be gotten from carbon, and these things are accumulated by the dead remains of plants and animals. So in order to really ascertain the age of that particular substance that is made by carbon, take for instance the coal, they have to use radioactive substance to dictate that. And that is mostly used by the archaeologists. Finally, they are used for the production of destructive hydrogen and nuclear bomb. You have heard of atomic bomb, you have heard of nuclear bomb. So these things are used to destroy them. You see the anti-bomb squad of the Nigerian police or army, when they say there is a bomb somewhere, they have to go and neutralize the bomb or deactivate the bomb. Sometimes they use radioactive substance to dictate where the bomb is in order to deactivate it so that it will not explode. So these are all the uses of radioactivity. Now, as good as these radioactivities are, they can equally be dangerous. So let's look at the danger of explosion. So what happens when these radioactive substances are exploded or they are being exposed? One, they can damage the skin. As soon as they are exposed, they can damage the skin. Radiations can cause cancer and affect the heredity of man's body. Now let me explain this. Heredity happens to be what is transferred from parent to offspring. For example, if your dad is tall and your mom is short, when they meet, you see that some of the offsprings are tall. So those tall traits are being transferred from parent to offspring. Sometimes the man might be dark and the wife is fair, and you see the children being fair. That is transferred through heredity in a particular part of the cell known as genes. So this radiation can affect that. And you see children burning without having any resemblance of their parents. You begin to wonder what happened. It's because of the danger of exposure to radiation. Let's look at the third one. Radiation brings about genetic changes or mutation. I don't know if you have seen or watched a documentary where people are born with 4 fingers. Some are born with very big heads. Some are born with 1 eye. It's because the chromosomes responsible for reproducing that particular cell has been washed away or has been changed. Mutation simply means changes. And this can only happen when there is exposure of radioactive substance. The fourth one is radioactive substance can cause sterility. Let me start with sterility. The ability of a man or woman not to be able to produce. Their reproductive system or seeds are destroyed. They are destroyed based on this exposure of this. And this thing we are saying mostly affect people that work with it. So if you are working with these substances and you are not careful, it can lead to sterility, your inability to procreate, and equally abnormality in the blood. One of the abnormalities in the blood is what we call the sickle cell anemia. It changes the blood shape into sickle cell and it becomes a crisis. Now let's look at the last one. Prolonged exposure to radioactive ray. Ray there means radiation, can destroy the body cells. When you expose yourself constantly on this, like going to take X-ray, going for scan, always you are scanning, you are X-raying yourself, it will destroy your cells. Now let's look at precautions. If you are working in a radioactive company, workers in radiology or radiological laboratories should always protect themselves by shielding from thick block or lead, or wearing iron coats or coverall. You see people wearing overall, You see people wearing shields and goggles. They are trying to protect themselves from this radiation. So if you are opportune to work there, you should equally do the same. Now let's look at laws of radioactive decay. There are two laws. The first law says that when an element disintegrates on the emission of alpha particles, it turns into an element with chemical properties similar to those of an element placed earlier in the periodic table. That means if this happens, it can replace an element. Just as I told you before, that alpha can replace this element in the periodic table, known as helium. So that is the law. You see it replacing helium completely. That is the first law. Now the second law says that when an element disintegrates by emission of beta particles, it turns into an element with properties similar to those of an element on a place later in the periodic table. So it will turn to an element that was placed before, it will just replicate it. So these two laws prove that radioactive decay actually happens in nature. I'm going to stop here, but I want you to try this at home. After reading your note, try this without even looking at your note and see how you can answer those questions. Question 1. Name 3 radioactive elements. 2. State 3 uses of radiations. And 3. State 3 damage or dangers from the use of alpha and gamma particles. Try this at home and submit online. If you have any difficulties, I'll be there to assist you. Thank you.